Hello everyone. In this video we will discuss the definition of continuous functions. These are functions where the limit agrees with the value of the function. Let's start with two examples of functions. So a good way of thinking of continuous functions are the functions whose graph can be drawn without lifting the pen. So let's see the first one. We could start around here and we can travel this graph without lifting our pen. In the second example, we can start drawing it, but now at this point we have to jump to get to the other part of the function. So we have to lift our pen, and then from there we can start traveling again. So in this case, we say that the first one is continuous and the second one is discontinuous. To be precise with this definition, we say that a function f is continuous at x equals a if all the following conditions are satisfied. The first one is the function has to be defined at a. So f of a has to exist. The second one is that the limit when x goes to a of f exists. And the third one is that these two values are the same. So remember that we saw some functions where the limit might not be the same as the value of the function. To be continuous, those two values have to be the same. If any of these conditions fails to be true, then we say that the function is discontinuous at x equals a. Finally, we say that a function is continuous if it is continuous for all real numbers. So this was the definition for x equals a. We will say that it's continuous if it's continuous for all the numbers. Some examples of continuous functions are the following. Every polynomial function is continuous for all the real numbers. So we say that all polynomials are continuous. Another example is that every rational function is continuous at all values of x except those that make the denominator equal to 0. So the ones that are not in the domain of the function. Let's try to see this definition in an example. So here we have the graph of a function f, and we need to decide where it is continuous and where it is discontinuous. So notice that the first point where it fails to be continuous, it's at x equals 1, because the first condition fails. So at x equals 1, f of 1 is not defined. The second example here is at x equals 2, where we can see that even though the function is defined, the limit does not exist, because from the left we're approaching to 3 and from the right we're approaching to 1. Finally, the other number where we have some kind of trouble is at x equals 3. Why is that? The value of the function is equals to 1, but the limit of this function, it's equal to 2. So the limit and the value of the functions are not equal. Finally, let's see how can we check if a function is continuous directly using its definition. So here we have a function f that is defined piecewise. So we have to check the three conditions to see if it's continuous or not. So first of all, notice that if x is less than 1, then the function is a polynomial. The same case happens when x is greater than 1. The function is also a polynomial. So the only potential problem with this function could be at x equals 1. So let's check that the function is in fact continuous at 1. To see this, we have to check all three properties. So the first one is we need to see what is f of 1. Well, notice that 1 is included in the second part of the definition of the function. So f of 1 is 1 plus 2, which is equal to 3. Secondly, we need to check that the limit when x goes to 1 of f exists. So to do so, remember, we need to compute the two one-sided limits, the one from the left and the one from the right. In this case, we will have that the limit from the left of f of x, it's equal to the limit when x goes to 1 of 4 minus x squared, which is equal to 3. And we can do the same thing for the limit from the right, which will be the limit when x goes to 1 of x plus 2, which is also 3. So because the two one-sided limits agree, we can say that this is equal to 3. And notice that with this, we're checking the third condition, that the limit that is equal to 3, it's equal to the value of the function, which is equal to 3. So the third, let's write it down. We have that f of 1, which is equal to 3, it's equal to the limit when x goes to 1, which is also equal to 3. So as a summary, continuous functions are the ones where the limit of the function agree with the value of the function, and they will play a major role in this class.